Hey everyone, today I'm going to talk about multi-stage build in Docker. As we know, more and more applications being containerized, creating an efficient and secure image is crucial. Multi-stage build in Docker provide a powerful way to optimize our image performance, security, and efficiency. In this talk, we'll explore the benefits of multi-stage builds and how a developer can use them to reduce the complexity and size of their images by separating the build environment from the runtime environment. In the end, we will also see a short demo. Before jumping into the presentation, let me first introduce myself. Hey, I am Pradyumna. I am DevRel at Lifecycle. I am DevOps and Go developer. I talk about open source. I create content on Twitter, LinkedIn, and write blog on them. Let's move ahead with the presentation. I will also put my camera down for better visibility. First, let's understand what multi-stage build is. When we break the building step of an image in a Docker file into multiple levels and stages, this is what multi-stage build is. Docker allows you to define multiple stages in a single Docker file, so you don't have to create multiple Docker files to use this multi-stage build feature. So this is an overview, the image we want and the image we build. So a good optimized image contains runtime and application. Sometimes it contains one or two elements more, but in general it contains application and a runtime to run it. The image the people generally build all the non-optimized image contains compiler, test code, build and test logs, runtime and application. So if we are running an application, there is no need of compiler. Why we need compiler in the actual application? Test code. We don't need the test cases when we are running an application in production. Actual code, we don't need that if we have executables. Build and test log. We don't need build and test log while running the application. The only thing we need is application and a runtime to run it. So this is a huge difference between the image we want and the image we build. Due to this extra code or extra elements, the image size gets so huge. So what are the problems? Like what are the problems with the current image we build? First and foremost is the security, and security is really sensitive and highly concerned topic. So if your image size is that much big, it becomes more vulnerable because you have much more surface area to attack on. So because you have more dependencies, you have much more factor, you have much more packages. So you never know which package or dependency might shortfall on the security side of things, and it becomes easy to attack. So it's really important to remove the unnecessary parts in the application itself. Second is performance. Slower downloads, bigger storage needs, and making the application run slow. For sure, if your image size is bigger, it will reduce the performance because you are building slower and pushing the image slower to your registry. So overall process and performance becomes slower. Efficiency, of course, the efficiency depends on the performance. If your image is taking time to build, and it's really hard to organize different part in the efficiency because, for example, if you have a CI which take 5 minutes to run and 4 minutes is take by that Docker image to build, even though you optimize the last part, 1 minute part, you still have this major chunk which is not optimized. So making your image optimized make this whole process optimized. So here is the gist of the things I explained over the slides. So if you are using multi-stage build in Docker, you need a single Docker file. You don't need to create multiple Docker file to use this feature. No, you can just have a single Docker file and use this feature. Less code. Of course, if your application contains less code, it's less to worry, less bugs and everything. So less code comes with less bugs. Same syntax for sure. Like if you are using multi-stage builds, you don't need to write a special syntax. No, you use the same from and copy statement and run statement in the Docker file. And in the bottom right corner, you can see I have created an image. This is how much you can reduce the size with the Docker multi-stage build. So this is an application which I recently built, which I reduced from 200 MB to 20 megabytes. So you can reduce any image size from 4 to 20 times. So I created this very basic Docker file to give you a better explanation. So in this, we have 4 stages. So in the first stage, we use a base image as LP and mark it as base image. You can see A as keyword. So we use as base. Secondly, we use Ubuntu image and mark it as first. And we are just running a hello command to create a hello file. When we run this file, we will get a hello print in our terminal. In the third stage, we are using Debian image and mark as second. and we are running a conference command and saving it as a conference file. In the final stage or the final image, we will use different elements from different images or stages and just copy into our final image. So you can see from base we are using the image of the first stage or base image. So secondly, we are copying this hello file from the second stage or the first image from the Ubuntu. In the third, we are copying conference file from the second image or the third stage, which is Debian one. And in the last, we are just running a cat command to print out both the things, hello conference. So you can see from different stages, we copied different thing. So we didn't copy the full Ubuntu operating system. We didn't copy the whole Debian system. We just use a base image and copy the elements we want from different images and just combine those things into the final image. So this is how we do it, like run different tasks according to our need. For example, some specific tasks can be run into specific operating system or specific environment. You can run those and get the output and just copy into final image. We don't need to keep that whole operating system in our image. No, there is no requirement. We can just use the element we want, and that is how we optimize the image. So let's see a demo in live. So here we are in VS Code. We are using a Golang application for the demo. So I created a very basic server with Golang using Gorilla Mux. So whenever we hit this localhost 9001, we will get an hello world. So let's run the application and check. So yeah, our application is running. Let me switch the window to browser. So if we go localhost 9001, so we can see hello world coming on the screen. I will reshare the VS Code. So let's have an overview how simple Dockerfile is different from multi-stage Dockerfile. So general Dockerfile look like this. We have a base image and we expose a port. We create a work directory, copy the files, we download the dependencies, we copy the rest of the files, we create executable out of that, and we run the executable. So in this Dockerfile, you can see we both have the creating of an executable as well as copying the whole app. So in the final image, we have both things, the executable as well as the whole file for the application. So when we are running an executable, we don't need the whole application, but in the final image, we have that. So let's have a look how multi-stage Dockerfile looks like. So in the multi-stage build, we have some common steps. So we have this from statement and we mark it as builder. We will use this later. So we have work directory, we expose a port, we again copy the files, and we download a dependency, we copy other files, and we create an executable. This is how the first stage looks like. We are using this first stage just to create this executable. So after we created the executable, we took an LP in image, and from builder is this one. From this image, we are copying that app executable and putting into the bin inside of this image. And we are just running this. In the final image, we don't need this application files because our executable is there. So why we need both things? This is why we use multi-stage. So we separated the build stage. So let's build both application and see how much the image size difference it has. First, let's build the simple one, the Dockerfile one. Okay, and let's build the second one with the multi-stage build. So we have both the images. If we do the Docker image ls, I will zoom a little bit. You can see the first image with no multi-stage build comes around 350 megabytes, and the second one which comes around 13 megabytes. So there's a huge difference between the image size because first one contains all the extra things like the dependencies, the application files, and other stuff. But in the second one, multi-stage one, we just have the executable and we are just running out. Let's finally run both images and see both have the same behavior and expected outcome. So let's first run an image with the multi-stage build. I will port forward so that I can access it on localhost. Go API. Let me switch window to the browser. 9001. It is working fine. Let me switch back to the VS Code. Let's stop this application and run the Dockerfile without multi-stage build. It will be Docker port forwarding to 9001 and images go API. It is running fine. Let me switch window to the browser. Localhost 9001. It is working fine. Let me switch back. So that was all about the demo. As you see, both applications have the same behavior and running totally fine, but the image size is so huge. Let me switch back to my slides. So yeah, this was the end of my talk. So thank you so much for watching. And if you want to connect with me, you can scan this barcode or just Google Pradyumna Saraf. And thank you so much, Michael, for this opportunity.